These are significance test notes 8 on the 2 sample z-test for difference of proportions. So we have a new test we're going to learn about, which you can call this thing I just underlined here, or we can also call it by kind of the shortened version, which is called the 2 proportion z-test. Just like any test, we always start with the hypotheses first. Because we have 2 proportions, your null hypothesis can be written kind of one of 2 ways. One way is saying that the 2 proportions are the same, which means there's no difference between the proportions. Of course, the alternative would be there is a difference, and it could be a less than or a greater than, or just the fact that there is a difference. The proportions are not equal to each other. Another way of saying there's no difference between the proportions is to say there's no difference. When you subtract them, the difference is 0. Or on the other hand, when you subtract the 2 proportions, you get something that is less than, or greater than, or just not equal to 0. The parameters are P1 and P2. So P1 is the proportion of all, whatever this first population is, that something. And P2 is also a proportion of all your second population, that something. There are 3 conditions for this kind of interval. And the first condition, similar to the 2 sample t-test, is that you have independent random samples. The second condition, similar to the 1 proportion z-test, is that both populations are at least 10 times the respective sample sizes. And be sure to make 2 separate statements here in context. And then the third condition is similar to what we had when we did the 2 proportion z interval. There are 4 separate statements in which every product of a sample size and its corresponding sample proportion should be greater than or equal to 10. As we move into step 3, when we carry out our procedure, we have a new formula to calculate our Z statistic. In the numerator is the difference of our 2 sample proportions, p hat 1 minus p hat 2. The denominator is a little unusual. It's the product of p hat, not p hat 1 or p hat 2, just p hat, times 1 minus p hat, times the product of 1 over n sub 1 plus 1 over n sub 2. You'll calculate z using this formula. Don't forget, because it is a z-test, you want to show a graph of a shaded bell curve as well as the p-value. Now, what's this p hat and how is it different from p hat 1 and p hat 2? P hat is known as the pooled proportion. And how it works is we have our individual proportions for each of our samples. We have p hat 1, which is equal to some numerator we'll call x1 over the sample size for that first sample, n1. And we have p hat 2, which is equal to x2 over n2. When we take a pooled proportion, what we do is we add the numerators of the fraction, x1 and x2, and we add the denominators. The idea of pooling is putting together, kind of adding together. So an example down here I'll use is if p hat 1 is equal to the fraction 5/10 and p hat 2 is also equal to the fraction 5/10, p hat is what you get when you add the numerators, 5 and 5, and the denominators, 10 and 10. 5 plus 5 is 10. 10 plus 10 is 20. P hat would equal 10 over 20. When you interpret your results, same interpretation as we've had in all the previous tests. As we move into the next page of our note sheet here, we're going to take a look at a problem from the 2004 AP exam that is going to use a 2 proportion z-test. What I'd like you to do is I'd like you to read through this example, try to work through the example and solve it out. Now, you'll probably run into some issues on step 3 this time, especially when calculating p hat. See what you can do with this. I'm going to give you an opportunity to pause the video, and then when we come back, we'll take a look at the solution to this problem. So this is a situation where the question is asking, basically, is there a difference in the proportions of banded birds? Is there a difference? Essentially means the null hypothesis is there's no difference, P1 equals P2, and the alternative is P1 is not equal to P2. You could also say P1 minus P2 equals 0 for the null hypothesis, and P1 minus P2 is not equal to 0 for the alternative. Our procedure is the two-proportion z-test. The parameter P1 is the proportion of all birds of a particular species on island A that have a leg band. P2 is the proportion of all birds of a particular species on island B that have a leg band. We need to talk about independent random samples. It does say random samples in the problem. We can assume independence because the birds are on different islands. We will assume that both populations are at least 10 times the sample sizes. In context, you could say, assume there's at least 10 times 180 equals 1,800 birds on island A. 10 times 220 equals 2,200 birds on island B. Our last condition deals with N1 and P hat 1 and N2 and P hat 2. You'll find in each of these cases we get values that are greater than or equal to 10. On to step 3. Your numerator is going to be the difference of the two proportions in the samples, 12 over 180 minus 35 over 220. I've calculated P hat over to the side, which is this pooled proportion. So I took the 12 and the 35, which are the two numerators. 180 and 220 are the two denominators. This totals up to 47 over 400. That is your P hat. So I've substituted that in for P hat. N1 is 180, N2 is 220. You get a Z that's negative 2.86. Because this is a not equal to problem, we're going to go to negative 2.86 on the graph and shade to the left, and we're going to go to positive 2.86 and shade to the right. Now you can use your calculator to calculate Z and the P value here. We're going to show you how to do that. We're going to go to Stat, Tests, go down to the two proportion Z test and hit Enter. We're going to enter in our two sample proportions, 12 over 180 for X1 and N1, and 35 and 220 for X2 and N2. We're going to use the not equal to symbol for alternative hypothesis, and we're going to calculate. And you'll see we get our Z-score of negative 2.855, which we've rounded. The p-value is 0.0043. If you use your tables, I think you'll get 0.0042, which is accurate at least to 3 decimal places. They also calculate p hat there. It says 0.1175, and indeed, that's what you get when you take 47 divided by 400. In conclusion, since our p-value is less than any alpha you'd probably choose, you could use 0.05, 0.10, or 0.01. I use 0.05 here since the p-value is less than alpha equals 0.05. We reject the null hypothesis. There is significant evidence that there is a difference in the proportions of banded birds on the two islands.